Okay, great. Our next presenter is Dr. Alan Fish, who is a thought leader in decision modeling and decision management. Alan invented the decision requirement diagrams and decision requirements analysis. He is the author of several very popular books about knowledge automation. He also an editor and co-author of OMG DMN standard. He is a co-chair of OMG DMN task force, and Alan represents another big vendor, FICO. And Alan is one of the most frequent presenter at DecisionCAMP, and I'm looking forward to your presentation, Alan.
Thank you, Jakob. Okay, so I'm going to be right. So it's the plan of my talk. I'm going to be talking about what I imagine as the cognitive enterprise. I'll talk about what cognition is. I'll talk about theories of agency, both at the individual level and at the group level, and about how automation has been used to enforce the group as an entity, as an agent in its own right. Then I'm going to be moving on to the metacognitive enterprise, talking about the difference between metacognition and cognition, types of metacognition, and the importance of formal models in supporting that. Along the way, I'm going to pick on some of the issues raised by Pierre in his excellent presentation, how to achieve a society of agents, what's required of agent specifications, human centricity, and how learning can be achieved using agents. And I'm going to try to directly answer Paul's question about the role of DMN in all this. So let's start with cognition. In this conference in 24, I presented the ecological view of cognition as described by Maturana and Varela. Life can be understood as autopoiesis, the process of self-creation. Processes occurring inside an organism create and maintain the organism. So life is a self-perpetuating cycle in which the organism continually makes itself. This diagram is from Maturana and Varela's classic book, The Tree of Knowledge. The circle represents the self-creating organism, and the arrows show how it interacts with the environment. The cycle cannot be fixed because the environment changes. The cycle must respond or adapt to the environment. The organism changes, remakes itself so that it survives. This is called structural coupling. The organism is said to be structurally coupled to its environment. And the example I gave at the time was the copepod, which is the planktonic crustacean that moves up and down in the water column in a daily cycle to avoid being eaten by fish in the daylight. The copepod is structurally coupled to the position of the sun in a way that helps it to survive. I then suggested that an enterprise could be viewed as a cognitive entity. In the same way, the behavior of the enterprise is determined by its processes, and those processes build the structure of the enterprise. The enterprise is structurally coupled to its environment through information feedback loops, and the enterprise survives by changing. It adapts its processes, and particularly its decisions, in order to continue to be successful in the market. Maturana and Varela stressed that in this model, cognition is not the representation of the world within the organism. It exists in the adaptive feedback loop between the organism and its environment. And although this viewpoint is very useful when considering ecosystems, which was the topic of my previous paper, it has limitations when you're thinking about the internal structure of the enterprise and how this could support cognition. More recently, there's a new viewpoint available provided by theories of group agency, and this will allow us to talk about the internal structure of the enterprise. So first of all, we should define what an agent is, and I'm basing this part of the talk on a book by List and Pettit, and according to them, the minimum characteristics of an agent are, and I'll quote these directly, it has representational states that depict how things are in the environment. It has motivational states that specify how it requires things to be in the environment. And it has the capacity to process its representational and motivational states, leading it to intervene suitably in the environment whenever that environment fails to match a motivating specification. An example they use is a simple robot moving around in a small area where there are some cylinders, some lying on their sides, some upright. The robot detects the position and the orientation of the cylinders, and if it sees any on their side, it moves over to them and stands them up again. If you knock one over, the robot will go back to it and stand it up again. List and Pettit contend you can really only describe the robot coherently by talking about its beliefs about cylinders and its intention to stand them up. And that, in effect, ascribes agency to it. And this is indeed how we talk about agents, including people. We talk about their beliefs, intentions, and actions. Now imagine a number of individuals in a group where each person is considered as an agent. For a set of people to be considered as a group rather than just some random collection of people, the group must have joint beliefs, intentions, and actions that outlive the individual members. So, for example, if passers-by spot a fire, they might collaborate to put it out, perhaps forming a bucket brigade. The bucket brigade has the joint belief that there is a fire, the joint intention of putting it out, and it will persist in carrying out that joint action, even if members of the brigade come or go. It can therefore be described as a group, even though it is small and hopefully short-lived. Larger groups would include choirs, sports teams, charities, universities, governments, even nation-states. All of these have joint beliefs, intentions, and repertoires of actions. And the group I'm focusing on for this presentation, of course, is the corporation or the enterprise. Now we have a philosophical question. Are we justified in talking about the group as an agent in its own right? And as framed by List and Pettit, there are three positions that you can take on this. One position is to hold that the concept of the group is redundant. All agency is individualistic, and group behavior results from individuals granting authority to other individuals. This is the authorization theory in the tradition of Hobbes and Locke and Rousseau. List and Pettit call this position eliminativist. It denies the reality of the group as an agent. This, of course, is the position that Margaret Thatcher took when she famously said, "There's no such thing as society." This position is equivalent to physicalism in the mind-body debate, which holds that the mind is nothing more than the biological processes that support it. Second position is that the group is not redundant and that agency is not individualistic. Group agency appears through emergence and is not reducible to the agency of the individuals involved. List and Pettit call this animation theory because it posits the notion of some mysterious life force beyond the members of the group. The equivalent at an individual level is the idea that the mind emerges from biological processes and is not reducible to them. The position held by List and Pettit they call non-redundant individualistic realism, which is to say that the group is real but not mysterious. It's real because it's not always possible to describe group beliefs and intentions in terms of individuals. You need to adopt, in regard to the enterprise, what Dennett calls the intentional stance. And it's not mysterious because the group is not emergent, rather it supervenes on the individuals. This position allows List and Pettit to suggest some design considerations for groups based on three desiderata. They're philosophers who use these sorts of words. There are three. There's the epistemic desideratum, which is that the group should maintain true beliefs through some form of aggregation of individual beliefs. It should provide incentive compatibility, which is that the group should be resilient to the individual rationality of its members. And there's the control desideratum, which is the group should organize individual actions into spheres of control that limit the autonomy of the individuals. These three can all be characterized as forms of alignment. Beliefs, intentions, and actions need to be aligned across the enterprise. Methods of alignment to achieve collective intentionality of group agents are so worked out by List and Pettit and also by Tuomela. I've included both of these references at the end of the talk. Before we started to adopt AI agents, the enterprise achieved much of this alignment through automation in the form of data, decision, and process engineering. Having a common set of data aligns beliefs across the enterprise. Decision automation aligns intent, that is, at the case level. It ensures consistent decisions are made on similar cases. And process automation aligns control. It limits individual autonomy to the actions allowed by the process. Automated processes manage all the interactions with the environment. Members have no option but to adopt its constraints when they're interacting with the environment. And as a result, the enterprise appears as a single agent to the external world. Now I want to step up a level and talk about metacognition. Metacognition is cognition about cognition, knowing about knowing, thinking about thinking, which has been a recognized topic in psychology since the 70s. At the individual level, metacognition has two components. There's metacognitive knowledge, what you know about your own thinking, and metacognitive regulation, based on that knowledge, how you plan, monitor, and adapt your strategies. At the enterprise level, metacognitive knowledge is what the enterprise knows about its current decisions and processes, and metacognitive regulation is how the enterprise adapts those decisions and processes to match its stated intent. I'll take these two components one by one. The enterprise holds knowledge about decisions and processes in the form of formal models. For example, DMN used to model decisions, and BPMN models processes. Such models are declarative and executable. When aligning the enterprise through automation, executability was the key. For metacognition, though, the key aspect is its declarative nature. Those of us involved with DMN have long argued that declarative models are important for shared human understanding of processes and decisions. Alignment of intent between individuals and the group requires that the enterprise's decision logic correctly represents what the individuals in the enterprise intend. This is much easier to achieve if the representation is a simple visual language that can be easily understood by people. This is the basis for OMG's stream of standards ending with MN. They comprise a model and a notation. The DRD notation breaks the domain down visually into a simple structure of decisions that have meaning to people. Now, declarative models have an additional role in our next phase of technological enterprise enablement. They'll be vital in deploying AI agents. AI agents act on behalf of the enterprise, therefore need to act in alignment with the enterprise's intentions and constraints. First wave of agents to be widely deployed were bots that interacted with customers, speaking on behalf of the enterprise. These soon expanded to AI agents acting on behalf of the enterprise by calling external APIs. These agents intervene intelligently in the interactions mediated by automated processes, effectively adding a layer of sophistication to interactions with customers, suppliers, and so on. Just like human members of an enterprise, the autonomy of AI agents is constrained by providing them with shared data, decisions, and processes. These agents are not necessarily executing decisions and processes. They are using formal models of those decisions and processes to guide them. The second wave of agents is the use of AI alongside human members of the enterprise, supporting them and extending their competence. We have to note here the danger of what's called the swarm approach to agentic support. If we provide each member with their own individual AI support using undifferentiated LLMs, this might increase their autonomy and actually disrupt enterprise alignment. AI agents must be aligned through access to formal models of the enterprise's processes and decisions. The simple visual language, so useful to people, also provides a simple ontology for AI. Pierre's terms, Agent specifications must be inspectable by humans, so should not be expressed simply in natural language, which is long-winded and makes it hard to discern structure. It should be expressed as, or at least should include, graphical models, especially process models and decision models. Agents then can have the opposite effect. They strengthen the alignment of beliefs and intentions across the enterprise, enhancing its status as a single group agent. The other important aspect of metacognition is regulation, the adaptation of processes, and especially decisions, so that they remain in line with some stated intent. Note, this intent is at a higher level than that defined as decision strategies. It is meta-intent, not how each case should be decided, but the business outcomes the enterprise wants to achieve over many cases. Meta-intent is typically specified as OKRs and KPIs. OKRs consist of an objective and a set of key results, and they're disseminated via management hierarchy, and each key result along the way is elaborated as a KPI target with deadlines. Typically, a business owner is responsible for a set of KPIs. Currently, the adaptation of decision logic to achieve KPI targets is almost entirely mediated by human activities. So, the owner consults regular reports of indicators such as KPIs created in some business intelligence system. They might delegate it to data analytics team to investigate causes of performance issues such as drift. They would simulate alternative remediation strategies and then discuss those and agree them with their colleagues. They have to update the decision logic and deploy the updated assets to production, and then monitor the performance of the new logic and so on through repeating that cycle. These activities typically impose lags of days or weeks and occupy a lot of highly skilled resources. If we want to use AI agents to support this task, we must represent the enterprise's meta-intent in an additional formal model, some form of business motivation model, which encodes the goals, strategies, and policies against which the outcomes of the decisions can be checked and adjusted. There are a number of business motivation models available. I proposed one at this conference in 2023, the Business Intervention Model, or BIM. I won't describe it again in detail now, but the key feature is that goals are represented as performance targets, such as KPIs. So by way of example, here is how we are using agents and meta-intent on FICO platform. Here we have a business owner and a set of operational decisioning solutions that he has a stake in. He's looking relaxed and a little bit smug because he has 3 intelligent agents acting on his behalf. The first agent is the performance monitor agent. The owner configures this agent by specifying their business intent as OKRs, KPIs, and notification criteria. The agent then monitors these KPIs against the owner's targets and generates notifications if targets are not being met or if measures are trending in that direction. The second agent is the change proposal agent. The owner configures the change proposal agents by specifying their intervention policy, when the agent should make proposals, and what decision assets should be considered eligible for change. This agent responds to performance notifications by analyzing the nature and causes of the problem, deducing which decision assets might be modified to address it, and using batches of simulations or optimization to find one or more possible interventions, changes to decision assets that look like they should remedy the problem. It proposes these options to the owner and can discuss, investigate, and test alternatives suggested by the owner by carrying out further simulations. The third agent is the lifecycle agent. The owner configures this agent by specifying their governance stance, the conditions under which they will pre-authorize scoped interventions, constraints on deployment times, the approvals required, and so on. This agent takes interventions prepared by the change proposal agent and handles all the lifecycle management activities involved in deploying a new version of an operational solution, and then documents the deployment as a new high-level entity, a business intervention, It records the motivation for the change, the nature of the change, the approvals gained, and the goals for the new version, a full audit trail at the business level rather than just the software level. The interventions implemented by the lifecycle agent close the loop on our operational decisioning solutions. So the three agents act cooperatively to maintain and improve operational performance in line with the business owner's intent and keeping the business owner in the loop at every stage. So, if I can start edging towards a conclusion, formal models encapsulate organizational knowledge into an explicit shared substrate that AI agents can read from, monitor, and crucially, for genuine metacognitive regulation, write to. Process models such as BPMN make explicit the who, what, and when of interactions between members and between the enterprise and its customers. They also provide a map of what would need to change if a process is adapted. Business motivation models, such as BIM, make the why explicit, the goals, strategies, and policies against which distributed actions can be checked for alignment, and the reference point against which adaptation is judged to be needed or successful. Decision models, such as DMN, make the how explicit, the decisions which determine how a specific case is handled. Together, these three model types convert tacit organizational cognition into something inspectable and adaptable by humans and AI, a meaningful step towards organizational metacognition. Decision models are the key here. They define both the actual object whose performance must be monitored, the decision, and the logic that must be adapted for metacognitive regulation to have any effect. So, to sum up, the cognitive enterprise, as a group agent, arises from the alignment of the beliefs, intentions, and actions of its members, both human and non-human. Achieving the metacognitive enterprise requires attention to the design of group agency. It involves self-knowledge, the alignment of group members on a set of shared beliefs and intentions, and self-regulation, the adaptation of processes and especially decisions in line with some shared meta-intent. Both of these require formal models, including process, decision, and motivation models. In particular, a declarative decision model, such as DMN, is a key foundational piece of infrastructure. It allows collective definition of the enterprise intent as the required response to each case, the cognitive level, and it allows precise, focused adaptation to bring those responses into line with collectively defined meta-intent, the metacognitive level. So my contention is that AI will not make decision models redundant. Rather, they will be an important constituent of agent specifications. Decision models will be vital in enabling the use of AI to achieve the metacognitive enterprise. There we go.
Okay. Okay, it was a little bit short than we expected, but it's not short on content. It's really not so easy to follow about every time when we talk about meta level, it's always requires additional thinking, and Alan is really good to force us to think this way, not just straightforward decision modeling. Okay, questions, please. While people is thinking, I would ask you, Paul is here. Paul, go ahead.
Thanks, Alan, and again, a very interesting session, and very thought-provoking. I was going to ask really how your model, the metacognitive enterprise, maps to the persona. So when you're doing a FICO discussion, for example, with an organization, are you talking to the enterprise architects, or are you talking at I don't know, more guru type C-level executives? I'm just wondering who are the persona to implement the theory, if you like, of your vision.
Yes, introducing this new level has involved us talking more to executive level, sort of CXOs and senior managers, and it has become clear to me that in the past, where we talked about collecting the requirements for a decision service, we talked to business analysts and experts in particular areas of the business domain. We really need to perhaps even start with the executives and the managers and find out what the intentions for the system should be. So I think there's an extra level of an extra type of persona that's involved in that process of requirements gathering and authoring. So certainly, if you want to build a system that can be maintained usefully over time in line with business intent, you have to design into it the KPIs that you're going to manage, you're going to monitor and manage as the basis for that feedback.
I'm guessing as ever that's a difficult task, persuading C-level execs that they need to have this level of meta viewpoint. But
no, I don't think so. I don't think so. I think most businesses have some form of performance objective specification and monitoring. The problem is that it's all entirely manual at the moment. I mean, the performance measures are gathered automatically, and you produce all sorts of lovely dashboards on BI systems. But after that, the process is entirely human.
Right. I would guess that those were very task-oriented rather than the more strategic viewpoints that you're presenting here. But anyway, I'm pleased to hear that it's acceptable. That's good to hear. Thank you again. A good session. Thank you.
Thank you.
Okay. More questions, please. You can see a question in the chat, Alan.
Okay, so is this James's question?
Yeah, James, you can.
Yeah. How does this compare with the Hungarian notion of a holonic model of agents and the enterprise? I'm sorry, James, you're going to have to explain that to me.
James, can you unmute yourself?
Yes. Yes. So, Alan, what the Hellenic enterprise would mean is it's part of a whole as well as an individual agent in itself. So it's more hierarchical in nature as compared to what you would call group agency. But it stemmed from the traditional multi-agent systems realm, where a whole-on is seen as agents fulfilling an enterprise goal overall. But it stemmed from the original work, The Ghost in the Machine, by journalist Arthur Corstel in 1967 book, and it's essentially been research in the multi-agent, in the traditional multi-agent, which is the BDI agent, belief, desire, intention, which has quite a bit of similarity in terms of the notions.
Yeah. And is the holonic model composable? Is it?
Yes, it's composable.
Multiple levels. Yes. Yeah.
Correct.
Yeah. And I see that as being a valid way to think this through. I'd like to get the problem solved at one level first, but certainly there's a good tradition in management cybernetics of thinking about the organization as a hierarchy of similar group structures, and I think that For example, that might map to the hierarchy of OKRs in many organizations. So it's quite an interesting thing to pursue.
Certainly. Thank you.
Yeah, thank you for that.
Lloyd, unmute yourself, ask the question.
Sure. Very interesting presentation. The angle on business motivation really struck me with that, something I hadn't really contemplated before, but I thought you were going to go to the BMM from the OMG, but you went to your own BIM. So maybe real quick, just talk about what the differences might be between the two. And then the second part of my question is, what is the means by which this understanding of the business motivation gets understood by the AI? Is it is it something where you say, hey, read this meta model and you're done? Or do you create something more like a knowledge graph or an ontology to inform it? What would you use to convey that understanding into the AI's context?
Okay, so the first question about the difference between BMM and BIM is mainly that the OMG's business motivation model is really based on the rules-based approach, and it maps to rule sets and the adaptation of individual rules. And I wanted something which would allow us to point to particular decision assets in some sort of decisioning structure. And also wanted to do more than simply model the motivation as such. I also wanted to model some of the constituents of the feedback system that allows them to address the changes to decision assets. So that's essentially the reason I produced my own model. Remind me of your second question. I'm sorry.
No problem. And thank you for that answer. That was clear. How would you convey the understanding of business motivation, however modeled, right, to be operational within the AI context? So it's like, just tell it to read the meta model, or you make a knowledge graph or an ontology or some other representation that it can be taught to interpret.
Right. Well, so the idea is that the business motivation is represented in this formal model, so it's easily understandable by any agent, as long as you give it the skill of experimenting with different versions of decision assets to try to achieve the motivation that is defined in that model. So it's quite a simple process, actually. You simply have to, well, it's not that simple, but you have to characterize the nature of the discrepancy between the outcomes you're seeing and the outcomes you want to achieve, perhaps by narrowing down the focus of the problem to a particular subpopulation of your portfolio. Then you have to look at the decision model to work out through dependencies which decision assets might actually be contributing to the performance measures that you're noticing the issue with. So here we have the idea of extending the decision model with dependencies to performance metrics. And then you have to run sets of simulations or mathematical optimization within a space that represents a range of alternative decision changes to a decision asset. For example, tweaking the value of a parameter in a rule, or changing the rules in a rule set, or whatever it is. Maybe you might even want to refresh an entire analytic model. But essentially, you're experimenting with alternative changes to the decision assets that are seen to be influential.
Thank you.
Yeah.
Okay, we have more questions. You can see on chat, or just unmute yourself and ask. Ellen, do you see chat question?
I see a question from Tallulah.
Yeah.
Have you considered using MBTI Enneagram, Ocean, or Big Five as control, tracking, and stabilization of the persona and the career field, providing the overlap you may need? And the answer is no, so I'll be very grateful to hear about those.
Okay. Alan, as you represent the second largest vendor in this area, I want to ask you the same question what I ask Pierre. FICO provides one of the most powerful optimization engine. And somehow during all our presentations, you or other FICO people never mentioned the use of this engine or integrated use of rules and optimization. Could you just comment on this?
Yeah. Well, I hope I've corrected that slightly today. But yes, in fact, and there are two options basically for trying to come up with an improved decision asset, one you think will return your system to meeting the intent. One is to run batches of simulations covering some space of possible solutions, and the other is to use mathematical optimization. But I think the mathematical optimization requires a specific design for a particular type of change. So I imagine we might have optimization. We might have specified particular mathematical optimizations for particular cases in advance, where we know there are particular types of decision assets that exist in a certain business domain, for example. Yes, we're considering using both anyway.
Okay. Okay, but they still like separate products not integrated yet.
Yes, indeed. Yeah.
Mm-hmm.
But what's nice about agentic engineering is you don't need to integrate all these tools into one vast monolith. They can call the resources they need.
Okay. Okay. We have time for more questions. Okay. Okay, if we don't have more questions, I still will allow myself to ask another one. You always concentrating on knowledge representation. And as you know, we have experts in knowledge representation, semantic web people, ontological experts in declarative AI. This is event co-located with DecisionCAMP, and it's running right now. And all these years we wanted, but we never had this real integration between our two worlds. But there are so many practical ontologies actually used, Accord, right, MISMO standards. And now when we're talking about use of ontologies together with agentic AI, it's probably time to start using them for more reliable services, for automatic guardrails, for reasoning, and when we automatically generate decision services. And what is your view of use of ontologies in this new environment together with business rules engines and other decision engines?
My view is that they provide LLMs with a clearly specified set of relationships between entities, so that if you point an LLM at some sort of policy document, then it's going to interpret that using the general public's understanding of how language is used, whether or not that's appropriate for understanding a particular type of policy document. Now, one way of getting around that is to use much more focused language models, which is one of the approaches we're taking in FICO. We have focused foundation models for particular business domains. The other is to have an engineered ontology that creates that structure for you. I think actually those two are going to combine over time, so that the LLMs will actually help produce the ontology that is then used by them to interpret documents. But the nice thing about an ontology is that it, again, that it's simply understandable by people and can be used to justify the results of the eventual mapping. But at the moment, funnily enough, LLMs seem to be managing quite well without them. That's the simple truth. I think that's why adoption has lagged. LLMs have been surprisingly competent in managing by going directly to the source of the language rather than grammatical models of it. So, but I do agree that there is a role for them, and I expect it to be coming.
No, I hope time is coming when we should be very close with them. And everybody talks about these loops today, and these loops should contain a call for ontologies to check generated code or generated logic in whatever way it's generated. And ontology could be probably the best guardrails and automatic guardrails. And this knowledge already present, so hopefully even this time or next DecisionCAMP, we will hear more about practical use of both ontologies together with our decision engines. Anyway,
well,
if
just to answer a side comment in your question, I do believe that we should be very wary of generating decision services directly from the source documents. We should instead be preparing a specification that includes graphical models that can be easily understood by people, and using that to build the services.
Yeah, of course. Yeah. Any more questions? If not, thank you very much, Alan, as usual, for very interesting presentation, and we will move forward after stopping this recording.